in a certain country, the true probability of a baby being born a girl is 0.479, or 47.9%, so a little less than 50-50. Now, among the next 4 randomly selected births in this country, what is the probability that at least one of them is a boy? All right, so this, at least at first glance, this seems like a situation where we want to use the complements rule of probability. And the reason we want to use the complements rule is, so among the next 4 randomly selected births, we need at least one of them to be a boy. Now, at least one means one or more. So let's look at the possible scenarios. Let's say boy and girl. Oop. All right, so if there's 4 kids, you could have all girls. So 0 boys and 4 girls. That's one possible scenario. Or you could have 1 boy and 3 girls. You could have 2 boys and 2 girls. You could have 3 boys and 1 girl. Or you could have all 4 boys. So these are the possible scenarios. And what we're looking for, we want the probability. So actually, that's before we talk about probability. The event that we're looking at, we'll call this event A, is at least 1 boy. Now, at least 1 boy means, like I said, 1 or more boys. So that is referring to all 4 of these scenarios, all 4 of these cases. So that's our event, at least 1 boy. So it could be 1 boy, could be 2, could be 3, or it could be 4. And the complement, so let's do a different color here. The complement of this event, if it's not at least 1 boy, the complement would be no boys. And so the complement could only happen one way. 0 boys and 4 girls. So this would be the complement of our event. And since there's many different ways that at least 1 boy could happen, but there's only one way that the complement of that, no boys, could happen, we could use the complements rule of probability, which says the probability of something happening is always equal to 1 minus the probability of that thing not happening. And so let's see if we can calculate the probability of the event A not happening, the complement of event A. And so this would be, so this right here would be 4 girls. Excuse me, so that's 4 girls, 0 boys. All right, well, if we look at child number 1, what's the probability that first child is a girl? Well, we know that's given in the problem. That's 0.479. And girl number 2, what's the probability of, or child number 2, the probability that child number 2 is a girl is also 0.479. And child number 3 being a girl, 0.479. And finally, child number 4 being a girl, 0.479. So 4 girls means the first one's a girl, and the second's a girl, and the third is a girl, and the fourth is a girl. Remember, and means multiply. The multiplication rule is the rule for and. So we're going to multiply these 4 numbers. Okay, so that means the probability of our event A, which is at least 1 boy, is equal to 1 minus the probability of no boys, which is 0.479 times itself 4 times, or we could say to the 4th power. All right, and that should do it for this problem. Now we just have to crank out the number. I'm going to bring up Desmos, the Desmos calculator. Okay, so let's bring it over a little bit this way. Okay, so that's 0.479 raised to the power of 4. Let's see if we could fit this all on the screen. But we have to do 1 minus that, because that's the probability of what we don't want. So the probability of what we do want, which is at least one boy, will be 1 minus that. So let me go back to Desmos, and I'll put in a 1 minus in front of that. And it looks like, as if we round this to 3 decimal places, it looks like 0.947. 0.947. And that would be, let's put that here. So the probability of A equals 0.947. So that would be the probability of, for the next 4 randomly selected births, at least one of them is a boy. And that's the combination of those 4 cases. All right, that does it for this problem. I hope this was helpful.